Okay, so we've created a bunch of nodes here, and this is just to kind of show you how casting works, how print string works, and so that now that we understand how those things work, we can go ahead and just delete these, and let's do some more interesting stuff now. So in the viewport, we can see that we have a box, and we've set the box to be the root component. We also have a sphere component, and we saw that we can create nodes that allow us to have functionality for overlapping with them individually, so that's good. Now that we understand that, I'm going to go ahead and delete the sphere component by selecting it and clicking and hitting the delete key. And so now we just have a box, that's the root, and we have a cone, and if we look in the world, we'll see that we've got our box and our cone here. And so I'm going to go ahead and take this box and move it back over here and just sort of let it stay there in the air. And I'm going to take our actor here with our box and our cone. I'm going to move it over here just in front of our ball. And now I want us to create some more interesting functionality. So if we go back to the event graph and we have our onComponent begin overlap for the box, notice we still have, pardon me, onComponent begin overlap for the sphere as well, but we no longer have a sphere, so this is no longer valid. We have to delete that. Okay, so now that we have onComponent begin overlap for the box, what I want to do is something more interesting. So as soon as our ball overlaps with this box component, what I'd like to do is play a particle system. Now I know that you've heard about, I've mentioned particle systems and that they're things like smoke and fire and exciting things like that. And what I'd like to do is show you how to spawn a particle system emitter. Basically something that will emit particles, and it's actually very easy to do so. So what I'm going to do is, first of all, on component begin overlap, for the box, we're going to take our other actor, and we're going to drag it off, and we're going to cast it to our physics ball. So cast to physics, and we're going to say cast to physics ball BP. And if this is a success, in other words, it's not a static mesh actor, it's not a box from the world, it's our ball, we're going to, on success, we're going to do something. And what are we going to do? Well, we're going to spawn a particle emitter. So type in spawn particle, and you'll see spawn emitter at location and spawn emitter attached. We're going to choose the spawn emitter at location function, and we get this nice big node that says spawn emitter at location. And you'll see here it says emitter template, and this has a drop down, and this shows us all of the particle systems that we have thanks to including starter content in this example project. So you'll see that we have a p-fire particle system. So go ahead and click on that, and now we've selected that for our emitter template. That's the emitter, the particle system that we're going to emit once we spawn a particle system. And now we're spawning it at a particular location. Now a location has a yellow data type, and yellow is reserved for vectors. Now a vector typically has three components, x, y, and z, just like our location has an x, y, and z. And this is referring to x, y, z locations in the world. And so if we left this at 0, 0, 0, then this emitter, this fire particle system, would be spawned at the origin of the world. And remember, the origin was down below the floor. When we set that box in a previous video to be at location 0, 0, 0, it went down to below the floor. So we don't want to spawn a particle system below the floor. We want to spawn it at a more relevant location. So how can we do that? Well, there's a nice convenient node called getActorLocation. If we right click and we type getActorLocation, you'll see that we have this getActorLocation function. If we click that, we'll see it's a blueprint pure node. It doesn't take an input or an output parameter, rather an input or an output execution pin. It simply has an output value called return value. And this, if you hover over it, it says return value and vector. And that's the type here. So if we connect these two, you'll see that we get that green check mark and we release. Then now we get the value from getActorLocation fed in to location for this spawn emitter at location node. Now getActorLocation gets us the location of the root component. So if we look in our viewport, the box component here is the root component, and the center of that is the location of this actor. So getActorLocation is going to get us the location of our root component. That's the box. So if we come back into the main level editor and click play, what we're going to do is we're going to collide with the box. And you'll see that as soon as we've done that, we've spawned an emitter, and that emitter shows us fire. That's the particle system, that P_fire that we chose. So we've just spawned a fire particle system. So that's actually pretty awesome. Now, if we wanted to, we could spawn this at a different location, and I'm going to show you a little bit about manipulating these vectors here in the event graph, because what if we say you want to spawn fire at the actor's location, but maybe not exactly, maybe we want to spawn it a little higher up above the actor's location. And we can do that by taking the return value from our getActorLocation node, dragging off of it, and we can type break, and you'll see that we get this break vector. So if we select that, then we get this break vector node, which breaks the vector into its X, Y, and Z components, respectively. And so we can actually take these values and do something with them if we want to. For example, the Z component, we can drag off of that. And because this is a float, floats have different functions that they can that can be used on them. For example, if we type float plus float, then we get this float plus float. We can click on that and we get a plus node. And what this does is it adds two floats together. Now we have an input for a second float to add to it, or we can just simply put a value in here. And so I'm going to click in here. It's by default set to 1, but I'm going to change it to 100. And so what this does is it takes this input parameter, the first one, which we're passing in Z from this vector, and we're adding 100 to it. So now the output of this is the Z component from our getActorLocation vector. And the output of this is that Z component plus 100, because we added 100 to it. So what can we do with this? Well, just like we were able to break the vector into its components, we can also take a float and make a vector from that. So if we drag off one of these floats, like the X component, for example, and type make vector, then you'll see that we have the option to make a vector. So if we click on make vector, we get a new node that takes in 3 float parameters, and what does it return? It returns a vector. And so what we're doing here essentially is we're breaking the vector of getActorLocation. That's the location of this actor. We're breaking it into its XYZ components, and then we're taking the X component value of that and simply feeding it into the X component for make vector. And we can do the same with the Y. So this is basically making a new vector that has the same X and Y components as getActorLocation. But then we can take the Z component from that, add 100 to it, and take that new value and drag that into the Z component for this make vector. So we're making a new vector that's the same as the return value from getActorLocation, only we've changed the Z, we've added 100 to it. So we take that same vector and add 100 to its Z component, and that will return us a new value that we can then plug in to the input location pin for spawn emitter at location. And what's the net result? Well, that will be basically we're going to spawn this fire template at the location of this actor, but it's going to be 100 units above, up in the air. So let's go back and hit play and see exactly what this looks like. So I'm going to overlap, and you'll see now the fire is above a little bit. And it may be a little hard to tell because 100 units is not that much. If we change this to, say, 500 instead and go back and hit play, then we can collide and we'll see that the fire is now 500 units above, up in the air. And so, so it's basically, what we essentially did was we took the location of my actor, we broke the vector into its components, we made a new vector, but instead of the z component from the old vector, we added 100 to it with that plus node, and then dragged that z component in. And then we dragged in the x and y components unchanged, and took that return value and plugged it into location. And that is how you can manipulate vectors and get to their individual components here in the event graph. So that's pretty nice. I do think 500 is a little tall, a little high. I'm going to change it to maybe 200, not 2500, but 200, 250 rather. And then we can come back in and see that now it's about, only 250 units above and not 500. So that's a pretty good point in space. So that is something a little more interesting that we've done now is actually spawning a particle system, and that's how we can add some more dimensionality to our games, because particle systems can add some realism and some excitement. When you see fire and smoke and things like that in a game, it just adds a little bit more realistic touch to it. So that is spawning an emitter. Of course, we used the cast node to make sure that it was a ball. So if a static mesh actor collided, then this cast would fail and we would not spawn the emitter. And just to prove it to you, why don't we bring this box over here and have it just above the overlap component. Hit play, and you'll see that even though it overlaps, we don't get that fire because we have tried to cast the other actor to a physics ball BP. The cast failed. We don't have anything connected to cast failed, only to when it succeeds. And so this will only happen when the ball itself collides. And then we got our location of our actor. That's this actor here. And we took that location, added 250 to its z component, and then dragged that into the spawn emitter at location so that we can have a nice particle system that we sort of spawn whenever we collide with the box component. So one last thing I'm going to show you before we end this video is something that I think is important for you to notice. We are spawning a emitter every time we overlap. Every time the ball overlaps with the box, we spawn another fire particle system. So if I come over here and then overlap with it again, you may not be able to see very easily, but if I overlap again and again and again, you'll see that there's more and more fire. So the more times we overlap with this, the more times we're going to spawn a particle system. And so right now we've got maybe 10 or 15 different fire particle systems all right in the same location, and that's not very efficient. So I'm going to show you a way to actually remove the particle system. So if we go ahead and escape and come back in here into our event graph, what I'm going to show you is as soon as we've spawned the emitter, you'll see that we have a return value, and its type is particle system component object reference. Now, we can actually store this reference in a variable. And one way to do that is we could go over here to the section where we can add a new variable, and we can click variable, and then we can come over to variable type, and we can search for that specific type. So it's particle system component. So if we type in particle system component and we hover over it, you'll see object reference. So we could go through all that and create that variable of that type, and we could call this, psys for particle system, and drag it in and type set or click set, and then we can connect these and connect these, and that will take the return value and store it into a variable. So that's one way to do it. But I'm going to delete that, and I'm going to delete psys, which was a bad name anyway. It's not very descriptive. But there's another way to do it, and that's when you take this return value, you can right click on it and you can click promote to variable, And that's essentially the same thing as creating a new variable and taking the variable type and choosing that, and it does that automatically for you. And so we can rename this, because new var underscore 0 is not a very good name either. And we can call this one fire particle system. And now we have a variable of type fire particle system, and its value is that returned from spawn emitter at location. So now we have a reference to it. Now, why do we want a reference to it? Well, because what I'd like to show you how to do now is how to destroy this particle system when we don't want it anymore. And what I'd like to, what type of event would I like to use to destroy? We already have, and we've seen how to create a begin overlap event. I'm going to show you now how to do an end overlap event. And this happens when an object stops overlapping with another object. So with the box component selected, I'm going to right click down here and type end overlap. And you'll see add on component end overlap. Very important that you use the component and not the actor end overlap. We've seen the difference between those two. So select the add component begin overlap. And what we're going to do for this one is we're going to take the other actor, we're going to cast to physics, and we're going to choose cast to physics ball BP. Now, if that succeeds, then that means the physics ball has stopped overlapping with the box. And in this case, what do we want to do? Well, I want to take our particle system, the fire particle system, so drag it out and click Get Fire Particle System. And I'm going to drag off of this, and we're going to type destroy, and you'll see destroy component. Now this is showing us functions related to the particular thing that we dragged off. And so it's showing us destroy component, and this is a node that we can use to, well, destroy a component. So we're going to connect this. Upon the successful cast to physics ball BP, as soon as we end overlapping with the box, then we're going to destroy this particle system component, and we're luckily able to do that because we stored a reference to it based on the return value from spawn emitter at location. So we spawned an emitter, we saved a reference to that emitter in a variable, and now we're seeing the value of variables because now that we've stored that reference, we can actually use that reference to destroy the component. So let's go back and hit play, and let's go ahead and overlap with the box. We'll create that particle system, and now what happens when we end overlap? It's destroyed. So we can create the fire, and then if we end overlap, we kill the fire, and then every time we overlap, we're creating a new fire particle system. But luckily, we'll only ever have one at any given point in time, so because we are destroying it every time we end overlap. So that is the end overlap event. And you can do things when, of course, things overlap with a component or end with a component, end overlapping. And of course, we do the cast to make sure that that thing that stopped overlapping is the ball and not anything else. And we saw that we can take the return value from a node and store that into a variable, and then use that variable later and call functions that are relevant to it. For example, destroy component will destroy the particle system. And then just to recap, there are two ways to do this. To create a new variable based on and feed it in the variable the return value from a node. And one way is to right click and click promote to variable, which we did. And then another is to simply add a new variable by clicking the plus here, and then coming up to variable type in the details panel and selecting the correct type. And remember, if you want to store something, a value of something in a variable, the type has to be the correct type. And so this particular variable has the type particle system component object reference, and we can type particle system component here, and we'll see that that is a valid type, and object reference is one of several different options here. And you don't need to really understand at this moment in time what these do. You're always usually going to select object reference, and that allows you to create a new variable of that particular type. So I'm going to select that new variable I just created and delete it. And that shows you how to create a new variable and set it. Now, next to variables, you've got the plus variable button, but you also have this add new button. If you click on that, you'll have a drop down that gives you options to create different types of things, and variable is there. So you can also use that button to create a new variable as well. So that concludes creating a particle system, and also how to destroy a particle system. And in addition to on overlap begin events, we also have on overlap end events as well.